Hi, have you ever tried this? You're watching a video and you have noticed a road sign, hoarding, or shop you wanted to read that address board. So you pause the video instantaneously, but instead of getting the picture or board, you got this. What? You had to make several attempts to achieve this. But what if you get this only in one click?
Hello everyone, today we are going to discuss exactly this. But first let's see how video works. Whether digital or old school film, video is a series of still images. When viewed in order at a certain speed, give the appearance of motion. Frame rate is the speed at which these images are shown or how fast you flip through the book, and it's usually expressed as a frame per second or FPS. Each image represents a frame. So if the video is captured at a playback at 24 fps, that means each second of video shows 24 distinct still images.
Let's also discuss the other technology which is involved in it, the display technology. Now, most of the earlier display devices use CRT cathode ray tube. It is still used in some instruments today, such as CRO. These devices were much bulkier and consumes a huge amount of power and generates a lot of heat. Components of CRT is an electron gun which fires electron at a phosphorus screen. Electric current is supplied to the heated filament which ejects the electron under the effect of applied electric field that causes electrons to accelerate and strike the screen. Their position where it will strike can be controlled by 4 coils which apply horizontal and vertical electric field to align the electrons to its proper position. As fast moving electrons strike a phosphorescent screen, it will produce a light to display the images. This kind of a screen dominated more than the 2 decades of the display device, mainly in the television. It may seem you boring, but bear with me. Later new technologies emerged such as LCDs and LED, which require much less power consumption than CRT monitor and were able to produce very good picture quality, and the thickness of the screen also reduced drastically. LCD screen basically works on the principle that specific molecules can act as liquid crystals. They can change their alignment as change in the applied electric field. In LCD screen, there is a backlight and 2 polarizer perpendicular to each other. Between these, there is a liquid crystal. If the rotation pattern of the liquid crystal is in such a manner that they rotate the incoming light into perpendicular direction, then it will be visible on the screen, otherwise not. Similarly, LED screens uses different color of LEDs to represent a pixel on the screen. Similar to LCDs, these screens also produce good picture quality and at low power consumption without heating the device. Due to their less power consumption and lightweight, these kinds of screens are heavily used in electronic devices ranging from small to large size.
But despite of all the changes in the display technology, the technology of displaying video on a screen remains the same. Modern digital camera record a video which is essentially a collection of large number of pictures, where each picture represents a frame. When you pause a video, there is a probability that you may hit the pause button just at the time when frame transition is taking place. The pause screen will show a still image which is neither picture from previous frame nor from the next frame. It will be a blurry image which have elements from both of the frames.
How can we get rid of this blur image? So to get over this effect, we can add a simple algorithm to our video players which can identify the timestamp at which a frame change occurs in the video. Now whenever the user clicks pause button, the algorithm will decide that the click time is closer to the timestamp of the next frame or closer to the timestamp of the previous frame. Based on that decision, it can show the previous or the next time. Applying this simple algorithm, we can get rid of this effect altogether. This can be very useful in the situation in which you are trying to see some details in the video such as CCTV footage, some text in video such as the address or the number plate of the vehicle, video from the satellite imagery, etc. Alternatively, this is done by taking a piece of the video footage from which you want to get more details. Extract all the frames from the clip and analyze the images one by one. But it consumes a lot of time, computational power and memory.
A video recorded at a high FPS will have a large number of frames in 1 second, which is achieved by the higher shutter speed of video camera. This allows the less transition time between the frames. So in case of higher FPS videos, there is a less probability to hit the pause button at the same exact moment of transition. Hence less probability of getting blur image when you pause. What do you think? What could be the culprit behind this? Let us know in the comment section below. Thanks for watching this video. If you have any suggestion regarding the video, please let us know in the comment section below. If you like the videos, please hit the like button, share with your friends, and don't forget to subscribe our channel to get update about our latest videos.